Hello everyone. So in this video, we will discuss the question number 1 NBHM 2025. So the first question is saying that x be the set of all real valued continuous function on the closed interval 0 1. So x is C01, right? Set of all real valued continuous function from closed interval 0 1. X is equipped with the metric. The metric is given by d of f g equal to integration 0 to 1 mod of fx minus gx dx, right? This is the metric, and they given us a sequence fnx equal to n when 0 less or equals to x less or equals to 1 over n square and 1 by root x when 1 by n square less or equals to x less or equals to 1. So this is the sequence. Now we need to check whether this sequence is Cauchy or not, whether this sequence is convergent or not. So let us recall a sequence. If xd is a metric space and a sequence xn in x is called Cauchy, if d of xn comma xn convergent goes to 0, instead of convergent we can say goes to 0 as mn tends to infinity. So let us take two natural numbers m comma n, where m is strictly greater than n or greater or equal to n. You can choose that. You can always choose it, right? Now let's see the behavior of fnx. Fnx is n when 0 less or equals to x less or equals to 1 by n square and 1 by root x when 1 by n square less or equals to x less or equals to 1. This is fnx. And fmx is m when 0 less or equals to x less or equals to 1 over n square and 1 by root x when 1 by m square less or equals to x less or equals to 1. Now the thing is that if d of fn comma fn is equals to integration 0 to 1 mod of fnx minus fmx dx. Now note that as m is greater or equal to n, I can say that m square is also greater or equals to n square, as both m and n are positive. So I can say 1 by m square is less or equals to 1 by n square, right? Now I am breaking this closed interval in three parts. So I'm just writing first integration 0 to 1 over n square, sorry, 1 over m square if mx minus fnx plus integration 1 over m square to 1 over n square fmx minus fnx dx plus integration 1 over n square 1 mod of fmx minus fnx dx, right? Now on the first part 1 over m square integration 0 to 1 over m square. Now let us see, as between 0 to 1 by m square, the value of fmx is m. So m minus, and note that as 1 by m squared is less than 1 by n squared, at that interval the value of fn is also n. So that is m minus n dx plus integration 1 over m square to 1 over n square. Now after that, from 1 over m square to 1, the value of fmx is 1 by root x. So in place of fmx, I'm just writing 1 over root x minus, and the value of fnx till to the point 1 over n squared is n. So in place of this, I'm just writing n dx plus integration 1 over n square to 1. After 1 over n square, the value of both of fnx and fmx is 1 over root x. So 1 over root x minus 1 over root x dx. So this part vanishes, and so I can write it m minus n into x from 0 to 1 over m square plus okay, I'm just breaking that. I can write it, and I can break this integrand in two parts from 1 over m square to 1 over n square 1 by root x dx plus 1 over m square to 1 over n square mod n dx. I'm using the triangle inequality. Now note that as both 1 by m square and 1 by n square are positive, so I can remove that modulus, and I'm saying that mod of 1 by root x is nothing but 1 by root x, and mod n is nothing but n. So in the next line, I can write m minus n into 1 by m square plus integration 1 over m square to 1 over n square 1 by root x dx plus integration 1 over m square to 1 over n square n dx. So this is nothing but m minus n by m square plus the integration of 1 by root x is 2 root x is from 1 by n square by m square plus nx, this is again 1 by n square 1 by m square. Now I'm just putting its values, so I can write this as m minus n by m square plus this is 2 into 1 over n minus 1 over m plus again I can write it as 1 by n minus m n by m square n by m square. Now note that m minus n is always lesser than m, right? 1 by n minus 1 by m is always lesser than 1 by n, and 1 by n minus 1 by m square is again always lesser than 1 by n. So I'm just using these three inequalities. I can write it is lesser than 1 by m plus 1 2 by n plus 1 by n, which tends to 0 as mn tends to infinity. Therefore, fn is definitely a Cauchy sequence. So we observe that fn is a Cauchy sequence. Now we need to check whether this sequence is convergent or not. To check whether it is convergent or not, first we need to find out its pointwise limit. Now to find this pointwise limit, note that if we choose a value x from between x in the interval open 0 close 1, we can always, by Archimedean property, we can always find a natural number n such that such that n square 1 over n square is always lesser than x. Now if 1 over n square is always lesser than x, I can write, in that case I can write the value of fn x is 1 by root x. Therefore limit n tends to infinity fn x is also 1 by root x, as this 1 by root x is not depending on n. So therefore for the pointwise limit of fn x on the interval open 0 closed 1 is 1 by root x, and 1 by root x has infinite discontinuity at the point 0, right? 0. But note that and if we try to find out is pointwise limit at x equal to 0, the value of when value of fn 0 is nothing but n, and limit n tends to infinity fn 0 is nothing but infinite, right? So its pointwise limit is not defined, or so we can say that this sequence is not convergent, although this sequence is Cauchy. We know that in a metric space, if a sequence is Cauchy but not convergent, then the metric space is not complete, right? So here let us see the options. So option A is saying that sequence is not Cauchy, so option A is not correct. Option B is saying that sequence is Cauchy, definitely then option B is correct. Option C is saying that the sequence is Cauchy but not convergent in X, this is again correct. Option D is saying that the sequence is convergent, so this is not correct. So option A and option B and option C is our correct option. You can see the answer is also given the same, option B and option C. So that's all about our question number 1.